Okay, adding and subtracting matrices. So you can only add and subtract matrices if they have the same order. So if the order, this one, so you can see it's a 2 by 2, and that one's also a 2 by 2. So what happens is you add the same spot of, in the matrix. So the A would get added, this B would get added with there, you can see there. C gets with the Y because they're in the same spot, and D with Z. So you can see you add the same spot, and it's the same when you subtract. So it's pretty easy. So if we look at this example here, we have a 2 by 3, and this is also a 2 by 3. So when they ask me to add them, I'm simply adding the same spot. So 2 plus 1 is 3, and so on. 3 plus 2 is 5, and you can see 0 plus 3 is 3, and so on. So pretty easy. I won't go through the minus one, but you've got an example there. Just be careful when you do a minus and a minus, that will become a plus. Now, this would be pointless doing these ones in your calculator. That would take you, guaranteed to take you more time than what it would in your head. So that's one of the ones where you go, right, I'm going to do it in my head quickly and manually. All right, so down here in this exam question, once again, question 1 of the exam, so pretty easy. So it says, consider the following four matrix expressions, and it says how many of these four matrix expressions are defined. So what defined actually means, defined means you can actually perform the operation. So you might write that. You can perform the operation that they're asking you. So what I mean by that, you can perform the addition, the subtraction, or the multiplication, whatever. So you can only actually add matrices when they are the same order. So if you look here, this is a 2 by 1 and this is a 2 by 1. So yes, I can do that one. So this one is defined because it can be done. If you look over here at this one is a 2 by 1 with a 2 by 2. You cannot add them. They're not the same order. So that operation cannot be done. So that is called not defined. Yeah, and if you tried to do it on your calculator, it'd probably tell you undefined. So therefore, if you look, the only other one that you can do is here because it's a 2 by 2 and a 2 by 2. So how many of these can you do? 2. And there's your answer there. Okay, moving on. This is question 8. This is following on a little bit using some of that ruling that we did yesterday with the I and the J. And as I said, this is question 8 in exam 2015. So this was probably when it started to get used a lot and kids did not go too well in it. So it says the order of matrix X is a 2 by 3, and then they've said that I represents the row number and J represents the column. And then they've given you a formula of how to work out matrix X. So what you're actually thinking about, so you go, all right, I've got matrix X here, and it's going to be a 2 by 3. So if you think about it, you might go, all right, it's going to have, you're going to have 2 rows and 3 columns. So I sort of like to do this often and just write, well, I'm going to have that many elements, and I like to do it lightly in pencil and then I can see. So let's go back and see what we're actually going to do. So if this is, remember this is I, so we've got 1 row, 2 row, and then J is the columns, 1, 2, 3. So if the formula says I minus J, this one would be 1 minus 1, wouldn't it? And this one would be 1 minus 2, and this one would be 1 minus 3, 2 minus 1, 2 minus 2, and 2 minus 3. So can you say that's what I would be doing to work it out? So which you could essentially write that as a matrix subtraction formula, couldn't I? I could have the original row numbers so these were all row 1, this is all row 2, and then I would be subtracting all the columns. So this is column 1, this is column 2, this is column 3, and this is column 2, column 1 even. Column 1, column 2, column 3. So that's how you could write that calculation out like this, couldn't you? With one matrix minus the other. So A ended up being the answer. I'm tipping that the why it was a little bit difficult was this I and J. It's often forgotten about by the time you get to the end of matrices, because it seems pretty simple, would you think? Yeah. So today we're just going to look at scalar multiplication, and what we're doing, a scalar multiplication is when you have a number at the front of the matrix. Not another matrix, a number. Okay, so with the number, what you do is the number just multiplies every element inside the matrix. So they're pretty easy. A scalar just means it's a number. It can be a fraction as well, or a decimal, whatever, but it's not, what it isn't is a matrix, another matrix. We'll do that next lesson. All right, so if we've got 3 times A, what we really have is matrix A with a 3 out the front of it. So you just multiply everything inside. So 2 times 3 is 6, 9, 0, 3, 12, and 6. So that's pretty easy. If you have half, so if we've got C written out, it could look like this. Now, you've got to remember, when you multiply fractions, what you're actually doing is you're multiplying. So it's like saying 4 over 1. So when you actually multiply, what you're doing is you're going across the top and you're going across the bottom. And yes, you might go, I'm stating the captain obvious, but it will make you quicker. Some people are going to go type this in because they see a fraction and they hate it. So 4 over 2, this one would be negative 4 over 2, negative 2 over 2, or 6 over 2. And that can simplify down to obviously 2, negative 1, and 3. So obviously that is much quicker to do in your head than even typing it out. But if you get an ugly little fraction or a decimal out the front, just shove it in your calculator. Whatever you need to do, you just have to make sure, if you're going to do that every time, then do it and don't be indecisive and be quick about it. Yeah? So whatever does it quicker, do that. And if you had time at the end, I would probably do it in my head. If I just had time at the end, I might have had the jitters. I'm just going to type it in the calculator because I've got time. All right, so if you note here, they said that the order will result in the same, the matrix will be the same order. And of course it will. If you have a look here, if we look up here, A was a 2 by 3. When we multiplied it by 3, it was still a 2 by 3. And same with this was a 2 by 2. So this C was a 2 by 2, and here is a 2 by 2 as well. All right.